Our next challenge is BIV-Priv, Private Objects Localization, and the winner is tele-ai-a team. They achieved the bounding box map score at 58.84 and segmentation map at 58.41. And now let's hear their presentations.
We are working on few-shot object detection and location tasks. Below, we introduce the methods we use. Overall framework. For each category, we use only one sample. First, we augment the images and then train the grounding Dino model for object detection. Simultaneously, we utilize the annotated bounding boxes to extract the target regions for training the VizWiz model. During inference, we perform object detection using the grounding Dino model. The detected object regions are cropped and input to the VizWiz image classification model for categorization. After image classification, we further identify specific categories related to text. For this, we primarily rely on the llama adapter model. Other categories are directly considered as the final output. Combining the results from the above steps gives us our object detection outcome. Finally, we integrate the object detection results into the segment anything model to obtain the final instance segmentation results. Object detection module. We perform data augmentation on the images, including adjustments like light, motion blur, flip, rotation, perspective, and hue saturation changes. The augmented data is used for training the model. Note that the annotations need to be adjusted accordingly after data augmentation. The training process involves freezing the backbone network and fine-tuning the model by adding an adapter former module in the text image fusion part. Refining object categories. Although the object regions are roughly localized after the object detection module, the specific categories may not be accurate. To address this, we introduce the VizWiz model. For each category, we use only one sample and fine-tune the model after image augmentation. The trained VizWiz model corrects the detection results by refining the bounding boxes. These refined boxes are then input to the fine-tuned VizWiz model for classification. Despite these efforts, the recognition of text-related results remains less accurate. Therefore, we incorporate the llama adapter V2 model, which performs text recognition on text-related images and optimizes the category recognition based on keywords to determine the final detection results. Finally, we combine the detection results with the segment anything model to obtain the ultimate instance segmentation results. Final evaluation. Our final evaluation scores are as follows. Mean average precision, 0.5884. Average precision at IOU, 0.5647 for object detection. Mean average precision map, 0.5841. AP at 50, 0.5574 for segmentation. We introduce a method for one-shot object detection using open vocabulary detection. Additionally, we leverage multimodal large models such as VizWiz and Llama Adapter V2 to accurately classify target categories. In the future, for one-shot or few-shot tasks, we will attempt to fuse the image features of one-shot samples with its corresponding text features in our object detection model to improve the recognition ability of these samples. We found that fine-tuned open vocabulary detection algorithms can locate the position of targets, but category prediction is not accurate enough. Pure image-based algorithms struggle with solving challenging examples from daily life, such as distinguishing between business cards and credit cards, or books and notebooks. To address this, introducing additional semantic features becomes necessary. Existing multimodal large-scale models can work well in semantic feature learning. However, we still need to fine-tune those models to enhance its recognition performance for some less common objects.